again, the derivative of the integral is equal to the function. Okay, if the integral goes from a to x. Right? Part 2 is what we're going to use, which is a little bit more practical. Okay? Part 2 basically says if I'm looking to integrate something from a to b of f of x dx, okay, then that's equal to, and we've already established it. I'm not going to go through the proof in part 2. Okay? What I'd like to do is I'll show you part 2, we'll do a couple of examples, and then I'll let you guys work a little bit. But part 2 says that if I'm taking the integral from a to b of f of x dx, what's the only way we have to evaluate integrals before we talked about the fundamental theorem of calculus? Draw a picture and calculate the area, right? That's the way we did it before. All right? But now that we've tied it into the antiderivative, okay, we can say that the integral from a to b is actually the antiderivative at b minus the antiderivative at a. Okay? And again, you can kind of look through the proof of it. It's in your books, and it's not that exciting, but at the same time, that it should make a little bit of sense. Okay? That the integral is tied to our antiderivatives. All right? Does that make sense? Yeah?
Wait, so there's a difference between an integral and an antiderivative?
Not really. The integral is the antiderivative.
And the integral is also the area underneath the line.
Mm-hmm.
So how could you have an area at one point?
What do you mean?
Like, isn't f of b just like saying the integral at b?
No. No. Yeah, see, that's why I hesitated a little bit on saying the antiderivative was the integral.
Okay.
Because it is and it isn't. They're associated together, okay? But an if and only if, an equal sign, I wouldn't go that far. Because the integral is this right here, okay? Is the antiderivative of b minus the antiderivative of a.
So in this case, what is the antiderivative if it's not the integral?
Let's look at a couple of examples, okay? It might make a little bit more sense, okay? So let's do this. Let's just do this. If I asked you to find the integral from 0 to 3 of x plus 2, okay? If I asked you to find the integral from 0 to 3 of x plus 2 dx, this fits kind of the old ones that we did before, right? Could I draw that and find the area of the trapezoid? Yeah. If I sketch the picture here and look at this thing, 1, 2. So 0 to 3. Looks like this. 0 to 3 is going to be up here. So that's 2. What's this going to be? That's going to be 5. going to be 3, right? Does that make sense? So then we would say the area of my trapezoid is 1/2 times 3 times 2 plus 5. So then I'm going to get, that's going to be 7 times 3, so 21/2, which is 11.5. He's not here. So that's the old way, right? If I looked at it then and said, let me use this method, okay? What's the antiderivative of x plus 2? Now we need to think backwards a little bit, okay? Think backwards. What's the antiderivative? What if I took the derivative of it would give me x plus 2?
X squared plus 2x.
X squared plus 2x?
No. Can't be.
X squared plus 2x?
No.
That would work, wouldn't it? Because if I bring the 2 down in front, all right? So this is plus some constant, right? I could have any constant out there. So this is what my capital F of x is going to be, right? Well, when I start to think of this, my constant doesn't matter, does it? Ryan, are you with me? Because if I plug this in, if I put b in, right, and I put a in, basically I'm going to get b squared minus 2 plus 2b plus c minus a squared over 2a plus 2b plus c, right? My c's are going to cancel out, aren't they? Because if I add it and then subtract it. So when we evaluate definite integrals, really all I'm going to think of then is saying that the integral from 0 to 3 is going to be of x plus 2 is going to be the antiderivative evaluated at my upper bound. So it's going to be 9 over 2 plus 6 minus, this is my f of b, minus 0 over 2 plus 0. That's my f of a. That's going to equal 4.5 plus 6, which is 10.5, which is what I should have gotten here, not 11.5, right? Why did someone tell me that?
You also wrote it before you.
What did I do?
When you wrote your little example equation, you plugged in a b instead of an a. You erased it.
Oh, the same thing. Oops, sorry.
That's okay. Yeah.
What?
Nothing.
So, Olivia, does that kind of answer your question a little bit?
Yeah, I get it now.
Okay. Yes, it is the antiderivative. And when we start to evaluate indefinite integrals, we'll use this. Okay. We'll start to use this more, this kind of idea right here. Okay. But for right now, when it's bounded, we can think of those c's as canceling out. And so then I can evaluate this function at 3, and I can evaluate this function at 0. Okay.
Okay.
Does that kind of make sense?
Yeah.
Other questions?
So is that how we're supposed to always do it now?
Yeah. Yeah. So let's take a look at a couple of other examples. So it's going to challenge you a little bit in the fact that you've got to think backwards. And just like we came up with some of the rules for taking derivatives of different functions, you know, we'll have to do some different stuff.